Texas Math Mundo audience. Today we have an addition to our instructional series. The topic, Vieta's formulas. Vieta's formulas relate the coefficients of a polynomial to the sum and product of its roots. That right ahead, let me take a quick moment and ask that if you enjoy this content, that you hit the subscription button and the notification bell, that you leave a comment below, and that you smash that like button. It helps me with the YouTube algorithm. Let's spread this joy, let's spread this beauty to as many people as possible. Vieta's formulas, relating the coefficients of a polynomial to the sum and products of its roots. Right ahead. Alright, so we start off with a statement of Vieta's formula in the quadratic case. So in the quadratic case, what Vieta's formula says, if you have two roots, in this case r sub 1 and r sub 2, that the sum of the roots can be obtained by taking the opposite of the linear coefficient and dividing it by the lead coefficient. And the product of the roots can be obtained by taking the constant, dividing it by the lead coefficient. And this is not so hard to derive. You can simply take the formulas as given, the answers, the roots, as given by the quadratic formula, add them, multiply them. After a little bit of algebra, you'll see that these results pop out. What also you could do is, I like to look at it this way, is if you have roots r1, r2, that means that x minus r1 and x minus r2 are linear factors. And you might have a lead coefficient there, but after some foiling, what you end up with is you end up with x squared minus r sub 1 plus r sub 2. This is after you expand x, and then plus r sub 1, r sub 2. And again, with the exception of possibly having a lead coefficient, you can compare it to the quadratic form. And what you see is that the sum of the roots will be the opposite of the linear coefficient divided by the lead coefficient, and that the product of the roots will be the constant divided by the lead coefficient. So that's not so hard to see. So what I like to do is I like to go ahead and let's do the, I'll fast forward to this. Let's go ahead and do the algebra for a third degree polynomial, and then we'll, some patterns will be revealed and we can tackle some problems. We'll do 3 problems ourselves, and I'll give you 3 problems to work on. So let's look at the cubic scenario, and this will reveal some patterns. So let me go ahead and move this up to the upper left. So in the cubic scenario, you would have roots of 1, 2, and 3. So let me write them. And so the factors would be with the possibility of lead coefficient as well. X minus r1, x minus r2 times x minus r3. So I'm going to do the algebra. I'll fast forward to this part so it won't take forever, but I'll show it in fast speed. All right, there's some patterns to pay attention to here. R sub 3. All right, so there's some patterns to pay attention to here. If we compare it to the cubic, squared plus cx plus d. All right, so the first thing to really note that's big important is the alternating signs. So the sum of the roots taken one at a time is still the opposite of lead coefficient, and you might have to divide opposite, of the quadratic coefficient, the second one. The sum of the roots is still the opposite of the second coefficient when it's put in standard form, and possibly over a lead coefficient. But now in the quadratic thing, the product of the roots was simply the constant divided by lead coefficient. In the cubic, it's now opposite the constant divided by the lead coefficient. So keep in mind the alternating signs. And notice that when you write it in standard form, the in the nth degree polynomial, the nth minus 1 will be the sum of the roots. The following will be the sum of the roots taken 2 at a time. And the constant will be the product of the roots. So this is a pattern to take note of, and we'll utilize it heavily as we approach problems that are beyond, say, the quadratic, the cubic, and it goes forward in this pattern. All right, a pattern to note. Let's do some problems. All right, so the first problem on tab is from district, the year 2023, number 7. So last year's district. And they give you a polynomial, a quadratic in this case. And let me get my pen going. And they say, so you got your quadratic, 7x squared plus 14x minus 105. And the roots are a and b. Says if the value of the roots of the function are a and b, then what's the sum of the roots divided by the product of the roots? Well, in this case, we just used what we derived earlier. The sum of the roots is always the opposite of the linear coefficient divided by the lead coefficient. So that the sum of the roots would be a negative 2. And the product of the roots, so that's a plus b. And the product of the roots is simply the lead coefficient, the constant divided by the lead coefficient. In this case, it's negative 105 divided by 7. And so negative 105 divided by 7 is a negative 15. So that becomes 2/15. And 2/15, I believe, is 1/3 forever. Let me see where my TI Inspire says. 2/15, 0.1333 forever. All right, cool. And so your answer is B. Well done. All right, let's go on to the next one. All right, our next problem comes from the year 2023, again last year, the UIL B release, number 27. They say the roots of the equation 12x squared plus bx plus c equals 0 are negative 1/3 and 3/4. They'd like you to find the sum of the coefficients, the linear coefficient and the constant, b plus c equals. So keep in mind that in a quadratic, the sum of the roots, so in this case negative 1/3 plus 3/4, is equal to the linear coefficient, opposite the linear coefficient, divided by the lead coefficient. And so we got ourselves a little problem to solve. If I multiply everything by 12, I end up with a negative 4 here. And then 3 times 3 is 9. Is equal to a negative b. So I end up with 5 equals a negative b, and so b is equal to negative 5. And the product of the roots, in this case negative 1/3 times 3/4 is equal to the constant, in this case c, divided by the lead coefficient, 12. The 3's cancel here. Multiply both sides by 12, and I end up with a negative 3 is equal to c. And when I add them, b plus c is equal to a negative 5 plus a negative 3 equals a negative 8. And our answer is A. All right, now on to the next problem. Takes us to the year 2021. Number 30, UILB release, number 30. It says the roots of the equation 8x squared minus kx minus 15 equals 0 are negative 1.25 and r, find k. So in this case, what I'm going to do is I'm going to utilize the product of the roots to get r, and then the sum of the roots to get k. So in this case, getting my pen, from the product of the roots, we know that I'm going to, instead of negative 1.25, I'm going to put negative 5/4, so it's easier for me to do the calculations that way, times r will equal to the constant, which is negative 15, divided by the lead coefficient. The negatives will cancel out. And to get r, I just simply multiply by the reciprocal. So r is equal to 15/8 times 4/5. And a lot of cancellation happens. That's 3. That's 1. That's 2. So r is equal to 3/2. So now for the sum of the roots, so now I know I got a negative 5/4 plus 3/2. has got to equal to opposite the linear coefficient, which in this case will be just a positive k, over the, opposite the linear coefficient, yes, over the lead coefficient. And so if I multiply everything by 8, I end up with a negative 10 plus, and then the 4 times 3 is 12, is equal to k, and k will then equal to 2. D. All right, so let's go on to the next problem. We go to the year 2019, UIL number 26, and notice we have a 4th degree polynomial here. They say the roots of the 4th degree polynomial are p, q, r, and s. Find the sum of the roots, and plus the sum of the roots taken 3 at a time, minus the product of the roots. So for the sum of the roots, it's always the opposite of the second coefficient, in this case the cubic, over the lead coefficient, so negative 1 will be the sum, plus the roots, the sum of the roots taken 3 at a time. So that's taken 1 at a time, 2 at a time. So here it's 1 at a time, 2 at a time, 3 at a time. And keep in mind the alternating signs. So that's opposite, the same, opposite. So it's going to be opposite of negative 1 over the lead coefficient, so it's just going to be 1 over the lead coefficient, so it's 1. Remember that there's a pattern, opposite, the same, opposite. In this case, opposite of negative 1 is 1, over the lead coefficient is 1. And so the sum of the roots taken 3 at a time was 1. And finally, minus the product of the roots, and let's look at it's opposite, the same, opposite, the same. So in this case, it's just 6 over the lead coefficient. The 1's cancel out, and you're left with an answer of 6. Nice and simple. If you pay attention to the patterns, the answer is 6. So now I have a sequence of problems I'd like you to do. So you'll pause the video and try these tests. So the first problem I'd like you to try is from the year 2019, the UIL number 43. So there it is. Let P and Q be the roots of that quadratic. Keep in mind it's equal to 15, not equal to 0. And they want the product of the sum of the roots and the product of the roots. All right, get to work, and I'll show the work here. All right, so our answer is E. I hope you got that. Again, it's just applying our theorems. So the next problem is from the year 2021, UIL number 45. And there's a little twist to this one. It says let R1 and R2 be the roots of that quadratic. Notice C is left as a variable. Where the ratio of R1 to R2 is 5, find C, the constant term. All right, guys, pause your videos and work on the problem, and I'll show mine fast speed. .625. So your answer is 0.625. Good stuff. Good stuff. Last problem, we go to the year 2020, the district release number 38. Statement says let P, Q, and R be the roots of that cubic. Notice it's a cubic. They basically want you to find the sum of the roots minus the product of the roots. Remember the pattern. Okay, guys, pause your video and start working on it. And so your answer is B, 5.5. Cool. All right, Texas Math Mundo audience, I hope you enjoyed that discussion. I hope you learned something. All right, let me take a quick moment and ask that if you enjoy this content, that you please hit the subscription button and the notification bell, that you leave a comment below, and that you smash that like button. It really helps me out with the YouTube algorithm. Let's spread this joy, let's spread this beauty to as many people as possible. All right, so thank you very much for your support. Hope you learned something. My name is Saul Cantu, and this is Texas Math Mundo. Farewell, farewell.